All right, welcome back, class. This is problem of the day cheat sheet for week number 4, page number 4. And our problem reads as follows. An apple is launched directly skyward or upward 64 feet per second, 80 foot from an 80-foot platform. The equation of this apple can be modeled with the function below. So it's asking me and you to make a table and to annotate the table with the y-intercept, the vertex, and the roots and zeros. So quick reminder, when we think about what our y-intercept is, again, this is the y-axis, x-axis. Y-intercept is going to represent the point on the function that crosses the y-axis. Whereas our x-axis are the point on the function that crosses the x-axis. We commonly refer to them as roots or zeros. And there's two of them here. One we will use, one we won't. And then finally, our vertex is the spot on the function that is the either maximum or minimum. So we are going to actually find the coordinates and put them in a table form. Take a couple of seconds, pause the videos, and work on that. Okay, welcome back, guys. So if you were successful, you were able to put our function into your graphing calculator, and you were able to produce the following table. So let's kind of look at this table together. So when I have x is 0 and, well, when I have x is 0, that's where my initial starting value is going to be. And I see here my starting value is at 80. So when x is 0, y is 80, that's represented by the red. My apex, or my vertex is represented by the highest point in the graph. And here we go, we're going from 80 to 128, going up to 144, going up, 128 going down. So 144 represents my highest point. That's my vertex. So after 2 seconds, I'm this far in the air. And then finally, I'm going back down to earth. So when my time is 5 seconds, my height is 0. So there we have it, our y-intercept, our vertex, and our roots. Let's consider the next question. What do we call the max or minimum value? You used this word already. It's called the vertex. How many seconds will it take for the apple to reach the ground? From our chart here, we have found it's going to be 5 seconds. Okay. Consider the next question. A football player attempts to kick a field goal. The path of the football can be modeled with the function below, where x is the horizontal distance of the kick and the height is the height of the football off the ground is that's what h of x is. All right, so the question now becomes, what is the vertex? All right, pause the video, take a couple minutes, put this in your calculator, and come back to me when you have that. Okay, class, welcome back. So by this time, you should have put the following function into your calculator, and it creates this very interesting parabola. Let's examine the questions. Okay, first question was, so we're going to look to determine the vertex. So here we are. Remember, one of the skills that we've reviewed is going to second trace, looking for the maximum, which is number 4, establishing a left boundary and a right boundary. So we're going to say our left boundary is, say, 0. And we're going to say our right boundary, or say 100. And then we're going to have the calculator guess for us. So it is guessing that our vertex is 75, 25. So in context, we're saying that after the ball's kicked, it's going to travel a horizontal distance of 75 feet and a vertical distance of 26 feet. All right, and we'll just label that right on our graph. There's your vertex. All right, now the question is asking, imagine that we have a 10 feet goalpost that's 105 feet away. Will the ball be high enough to pass over the goalpost? Well, clearly, if you're looking at the picture, you'll see that if the ball starts here and comes down here, it's way long enough to make the field goal. But that's not just enough for our regents. We have to be able to, right here, justify your answer. So a more complete answer is, instead of saying, yes, it will be long enough, look at the graph, is we actually want to be precise and say, yes, the ball will clear the goalpost because its height is greater than 10 until it covers a distance of 135 feet. Where did I get 135 feet? I looked at the function and I see my function doesn't reach to the 10-foot threshold until it gets to at least 135 feet. All right, and we remember our goalpost is 105 feet. So we're plenty close enough to say that the ball will clear. Okay? All right. Come on back for our next page, and I will talk to you then.